Today we're learning 2.1, comparing, ordering, and rounding decimals. We should be on page 52 in our books, page 52. All right, now the first thing you need to know, and this might seem a little elementary, okay, so just bear with me because we all need to be on the same page. You need to know your place values, okay? This is very important in chapter 2. Basically, if you don't know your place values, you're probably not in good shape to do well on Chapter 2 tests. So, if you don't know them, please learn them quickly. We go from the ones place, we go ones, tens, hundreds, thousands, 10,000s, 100,000s, and into the millions, and we know that it keeps going on, 10 millions, 100 millions, billions, and so on. Now, more specifically, in the decimal place values, we go from the tenths to the hundreds, to the thousands, to the 10,000s. It's very important that you know that. If you don't, please learn it tonight, okay? Don't wait. So know your place values. Know your place values. Now, in example 1, we're comparing decimals. We're trying to see which decimal is bigger. Okay, so we have 22.5. And we have 22.12, okay? We have these two numbers. Now, I'm going to start with the largest place value because if those numbers are different, then I know right off the bat which one's bigger, okay? So all I'm going to do is I'm going to start at the largest place value. And they are both the number 2, right? So it's the same number. So I'm going to keep going until the numbers are different. Well, in the ones place, they're both 2s. And then in the tens place, I have a 5 and I have a 1. Okay, so those numbers are different. So which one's bigger, guys? 5 or a 1? 5. So 22.5 is bigger. I put a greater than sign. Sometimes it's a little confusing which one's greater than or less than. Just remember it's always open to the bigger number. All right, so I know that 22.5 is bigger because I kept going. Once I get to the tenths place, 5 is bigger than a 1. We had a good question, okay? You can, if this is what you learned before, and I have seen a lot of students do this, you can add a 0, and you can say that 50 is bigger than 12. Is that what you're saying, Zach? Yeah, you can say that 50 is bigger than 12, and again, you're still going to know that 22.5 is greater. So if that helps you to add a 0 so there's the same number of digits in the decimal places, that's perfectly fine, okay? But really all you need to do is just look at the first place value that the numbers are different and see which one's bigger. All right. Everybody have that down in your notes?
Yes, ma'am.
Everybody have it down? All right. Now in example 2, okay, this is a little bit of writing, but I'm going to show you on a number line how this looks. Okay? Hold on. No, not that. Not that. That's just, okay. This picture, let me explain this. The reason why I put this in the PowerPoint is to show you how the numbers on a number line relate to the number 0. Notice that everything to the right of 0 is positive. The larger the number, the greater the value. Everything to the left of 0 is negative. And the larger the negative, the smaller the value. The farther it gets away from 0, the smaller in value it is. Okay, so that's the only reason that that's up there. But I do need you to write this in your notes, okay, this number line. No. Too far. There we go. Okay, so go ahead and write this number line. Now, if I ever give you a number line problem on a quiz or a test, I will give you this number line. I'm not going to mess with trying to, get y'all to figure out what values to put on the number line just yet. Okay? But I do want you to see how the numbers are ordered on a number line and how we do that. Okay? So this is basically how we set it up. The large dashes, these large dashes right here, that you see at 2.0, 2.1, those represent the tenths values, right? 2.0, 2.1, 2.2, 2.3. What do you think these small dashes represent? What number or what place value do you think they represent? What place value? What do you think? We know the large ones are the tenths place, so what would be the little ones in between? They would be the hundredths place. Very good. They'd be the hundredths place. Okay, so that's what those dashes, what place value the dashes represent. So now it gives me this data set, 2.11, 2.21, 2, 2.06, and 2.24. So all I'm going to do is plot these numbers on the number line. That's all. That's what I want to do, and that's what the instructions asked me to do. So starting with 2.11, that was really quick. Okay, I plot the point, and you can go ahead and write the value above it, or you can just plot all your points and then label them. And then we go to 2.21. We plot that point. Notice I went to 2.2 and then I went 1/100th over. And then the 2, it's going to be right on the 2. Oh, goodness. Keep doing that. Okay. And then 2.06. And then 2.24. Which I did that one over on accident. So actually I can change that right now. 2.24. All right, now you want to go ahead and label them. Okay, and I'll give you a minute to finish copying down that number line, and then we will write our answer. What comes first when I'm ordering least to greatest? What number? What number is the least? Yeah, very good. It's 2.0. 2, and then what?
2.1. 2.06.
2.06. Very good. Anybody besides McKee know?
2.11.
2.11. I meant 2.11. Hold on. 2.11, and then... Very good. And then 2.24. All right. Very good. Okay, and that is what you would box in for your answer. Okay, so on your notes, that's what you're going to box in for your answer. We use the number line to show how they fall compared to 0 and which one's least and greatest, but really all I'm concerned with is you being able to order them least to greatest. Now remember, you're looking at the first digit that's different and which one's larger or smaller, okay? So they're all 2s, so I have to look to the tenths place to see which one is smaller than the other. All right, any questions from example 2? All right, let's move on to example 3. In example 3, we're rounding, okay? You do need to know the principles for rounding. Remember, any number 4 or less, the number stays the same. If it's 5 or more, the number you're rounding we will need to increase it by 1. Okay? So it says round 7.126 to the nearest tenth. In your notes, say 7.126 tenth to the tenth. Okay? And then we're going to answer it. So this is a tenths place. I look at the place value to the right. Okay? So in this case, the 2 is there, so does my 1 stay the same or does it go up to a 2?
Stays the same.
It stays the same. So my answer is, class?
7.1.
7.1. That's it. Okay, whatever place value I'm rounding to, that's going to be the last digit in my answer. All right, now what about to the nearest hundredth? What number is in the hundredths place on 8.147? What is it?
4.
It is the 4. The 4 is in the hundredths place. All right, so now I look to the 7. The 7 tells me that the 4 stays the same or goes up?
Goes up.
It goes up. So what's my answer?
8.15.
Very good, 8.15. And I would box that in for my answer. You don't have to draw the little arrow underneath or any of that. You just say 8.15. Okay, and then what about 10.932 to the nearest whole? What would that be, Chris? What would my answer be?
11.
Very good. It would be 11. All right, and if you understand that, that's everything you need to know for 2.1.